Hello guys, welcome back to the channel. In this video, let us see how to solve a question on engineering drawing projection of solids. The question is like this. A pentagonal pyramid with sides of its base 30 mm and height 70 mm rest on one of its edges of the base. The base tilted until its apex is 50 mm above the level of the base on which it rests. Draw the projections of the pyramid when the edge on which it rests is parallel to VP and the apex of the pyramid points towards the VP. Let us see the step-by-step procedure how to solve this particular question of engineering drawing from projection of solids. So first thing is, they are asking for pentagonal pyramid of 30 mm and height 70 mm rest on one of its edges of the base. This is the initial condition. Now let us construct XY line followed by a pentagonal pyramid on its edge resting. 30 mm is the dimension followed by height is equal to 70 mm. I will call this line as X and Y line followed by VP by HP indicating first angle projection. So the first thing is I wanted a pentagon of 30 mm side resting on one of its edges of the base. I will go for first I will construct the edge position of a pentagon 30 mm, that is nothing but 3 centimeters in my normal scale. What is the angle of a pentagon? 360 degrees divided by 5 sides, that is the sides of the pentagon. So that would be 72 degrees. The interior angle is equal to 72 degrees. I will make use of protractor here. I will keep at this point and I will measure 72 degrees either sides. The interior angle is 72 degrees. The exterior angle would be 108 degrees. I have marked 72 degrees here, followed by I will mark one more 72 on the other side. 72 degrees is now completed. Now let me construct a line at an angle of 72 degrees. So this is 72 degree line followed by the next 72 degree line. The length of the pentagon is given as a 30 mm. I will measure 30 mm in my normal compass. So this point as a center, I will cut one arc, followed by this point as a center, I will cut one more arc. This intersection point, I will cut one more arc so to get the last point. From the other intersection point, I will cut one more arc so that the arc will intersect the previous arc. Now I've got a new point here. I will join something like this. So this is the pentagon 30 mm resting on one of its base. I will call this point as the point A followed by point B. This is the point C, point D and the point E. Let us go for the projection. Projection from the point C through the point D. Projection from the point A here. Projection from point B through the point E. We wanted the midpoint of the pentagon. If you are doing using software means midpoint is readily available, but manually we are supposed to obtain the midpoint. How do we obtain the midpoint? Just draw a perpendicular line from each corners. That means to say that from A, draw a line till it touches the opposite edge. That means to say that this is 30 mm. Draw a midpoint means exactly at a 15 mm. Just draw a line. One more thing, for the other side, mark 15 mm as the midpoint initially and connect it to the opposite corners. Now you can see the two lines are intersected at one common point. Let us call this common point as the axis. This is the midpoint of the pentagon. From the midpoint, project a line and give a rise of 70 mm. Why 70 mm? The height is very clearly mentioned as 70 mm. So this is the axis. Axis representation is a thin line, a big line, small line, big and small. We call this one as a chain line representation. So this would be 70 mm. Once we have got 70 mm, let us join the opposite corner, that is apex, as a pentagonal pyramid. So for the observer from this end, the point A is visible show as it is with the dashes indicating front view representation. Next, observer is looking from the bottom, B is visible, E is invisible, B visible, E invisible, keep it in the brackets, C visible, D invisible in the brackets. I repeat, dashes indicates front view representation. And there is axis passing through the geometry. I will call this point as a O dash of the axis, and this is O1 dash. Now, for the same observer, one who is looking from the top, suppose the observer is looking from this direction, O is visible, O1 is invisible, O visible, O1 invisible in the brackets. And very important, the slant lines are clearly visible. What is the slant lines? So make sure to darken a line connecting from O to A, O to B, O to C, O to D and O to E. So these are called as slant lines, slant edges or radial lines. So this is the first two position of the given question. Let me show the dimension. So we are moving from top view to front view. Let me show the arrow marks like this. I think the space is available. I will call this one as VP on HP, indicating first angle projection. This completes the initial position. What is the next condition? The next condition is the base tilted until its apex is 50 mm above the level of the base on which it rests. That is their telling. So if let us call this portion as the base of the pentagonal pyramid, and this is the apex, O dash is the apex of the pentagonal pyramid. Now it is tilted in such a way that the apex is 50 mm above the level of the base. That is what they are telling. Let us see how to obtain this one. Initially, first let us consider 50 mm from the XY line. After taking 50 mm, let us draw a locus line. Make use of a compass. C dash, D dash as a center and O dash as the radius. Take any convenient point here and cut an arc on the locus line. I will consider any convenient point. So from this point, C dash, D dash as a center, I will cut an arc on the 50 mm line. I will join, let us join these two lines. This point indicates a resting corner C dash, D dash, and this is the apex O dash. Now let us transfer the remaining points. C dash, D dash as the center, O1 dash as the radius, cut an arc. C dash, D dash as the center, O B1 dash, O dash, B dash as the one more arc. This corner as a center and A dash as the radius, the base, the complete base, let us transfer. But what is the intersection point for this one? So once again, O dash apex as the center and the corner, the other corner as the radius. Let us cut one more arc so that it intersects the previous arc. Now I've got the base portion of the pentagonal pyramid. Here I will name the base here. So this is O1 dash followed by this is B dash within the brackets E dash followed by this is A dash. Not to forget, O dash and O1 dash is connected with the help of axis line, and the other line is connected with the help of a thick line. So this completes position number 3. Next, let us go for the projections. I will drop a perpendicular Not to forget, I will drop a perpendicular from O dash. On the other side, let us draw a perpendicular towards the right hand side. Projection from the point A, also from the projection from the point O, I will extend it till the end point. Projection from the point B, so that it meets the previous projection at a point B dash here. Projection from the point C projection from the point D is well, and the last one is projection from the point E. So this would be the point A, projection from B, this would be the point B, projection from C, and C would be the point C. So this extra projections, if any, you can remove it. Projection from point D, this would be the point D, projection from point T would be the point T, and this would be the projection from point O1, and this is the point O. Observer is looking from this end. What is the condition of the apparent shape? One by one. Let us break down one by one. What is the condition of C dash and D dash? Since the observer is looking from this end, since this point is away from the observer or it is resting on XY line, C dash, D dash is invisible. Let us keep it in the brackets. And what is the status of C dash, D dash? That will be invisible line. So invisible line representation would be something like this. Thick dash lines. And what is the condition of O to O1? O to O1 is always the axis. Let us draw as an axis line. Big line, small, and big and small. Towards the side of the paper, we can write what are all the things that has to be drawn here. The first is A, B, C, D, E. The base geometry has to be constructed. We are supposed to construct a line from O to O1. We are supposed to draw a line from O to A, O to B, O to C, O to D, O to E. I mean to say that for the apparent shape and the sixth position here, these many lines has to be drawn. Okay, first is let me construct O to O1. Axis has been constructed. Followed by what is the geometry? A, B, C, D, E. Here is A, B, C, D, E. I will finish the construction. What happens if I extend a line from invisible point? So this point becomes invisible. Similarly, this point becomes invisible. I will finish this sketch here. This is the outermost boundary. Outermost boundary is always visible. So this geometry is constructed. Now what is the condition of O to E and O to B? O point is here, E point is here. Whenever the observer is looking from the top, O to E and O to B is completely visible. For that reason, it forms the outermost boundary. Please do remember the concept. Outermost boundary is always visible. On the same line of explanation, O to B, O to E is constructed, O to B. This also is visible. The reason because in the fourth position, that is the apparent position, O to B forms the outermost boundary. Henceforth, it is visible. Next, let us analyze what is the condition of O to C and O to D. Observer is looking from the top. C and D forms the farthest point from the observer. Henceforth, O to D is invisible. Or in other words, don't you think this is the invisible corner? If you draw a line from invisible corner, that should be invisible. Henceforth, O to D is invisible. On the same line of explanation, O to C also forms invisible line. Clear? So O to C is constructed and O to D is constructed. Left out is O to E. The last point. O point lies here, A point lies here. What would be the condition of O to A? Observer is looking from the top. Observer is very close to the point O and A. Henceforth, this becomes visible line. That is a straight, thick line, continuous line. But already a part of the line is O to O1 is axis line. So what happens? Remove the axis line. Upon that one, let us go for the straight line, continuous line. So this is how you are supposed to break down. Now, don't you think C and D is the resting edge? You should not show like this, but for understanding purpose I am writing. So this edge is the resting edge. The next condition is draw the projections of the pyramid when the edge on which it rests. Very clearly they mentioned that the resting edge, the edge on which it rests is parallel to vertical plane, parallel to the XY line. Clear? So there is a geometry here, this apparent shape. Now this side of the apparent shape should be parallel to the xy line. But what is the condition? The apex of the pyramid should be pointing towards VP. You can tilt like this or you can tilt like this. But if you tilt it in this way, the apex comes down. But the condition is apex should be pointing towards VP. That is what they are telling. So this is, as usual, this is the apex. Now how do we obtain the fifth position? Let me draw a perpendicular line first. Why? Because very clearly mentioned that the edge on which it rests is parallel to VP. I will draw a perpendicular line first. Let us start transferring the points one by one. Then any one point as the point O here, O as the center, CD point line as the radius. I will construct a small point. I will take it as a reference point. Next, O as the center, O1 as the radius. I will construct one more arc. Next, O as the center, the next point as the radius. Some imaginary point to obtain the point E and B. Next, O as the center, the last point A as the radius. So now this point is O1. Now let me transfer the remaining points. So therefore fifth position will be completed. Meanwhile, I will make use of protractor. I will mark 90 degrees, something like this. I will draw one line here, followed by I will draw one more line at this point, and last point I will keep as it is. Now make use of your compass. This imaginary point as the center, take the distance up to the point D. So from this point cut an arc so that you are getting the point D, and the other side you cut an arc, you are getting the point C, or any other method of transferring the points you can do it. The next imaginary point as the center, E as the radius. The next imaginary point as the center, E as the radius, cut one arc. The other side cut it towards the point B. So this is the point A, this is the point B, this is the point C within the brackets, this is the point D within the brackets, followed by this is the point E. A to B is outermost boundary visible. I mean the same sketch is transferred here. So this is how the sketch would look like. Let me project from top view to the front view and towards the right hand side so that I will get the plots for the last position. Projection from O and O would be the point O dash here. Similarly, projection from the point A and the projection from the point A would be the point A dash here. Projection from point B and the point B, B dash. Projection from point C and C, C dash. Projection from point D and the point D would be the point D dash. Last point is projection from the point E and the point E dash. It would be like this. Next, the observer is looking from this end. So the points would be the base of the geometry. Once again, do you remember for the apparent shape we have written few points? Let me write once again here. A, B, C, D, E has to be drawn. O to O1 axis has to be shown. Not to forget, there is a line between O to A, O to B, O to C, O to D, and the last point is O to E. These many lines has to be shown in the last position. Clear? Next, observer is looking from the bottom. The geometry is kept something like this. Now just imagine this eraser itself as a geometry. Now don't you think when the observer is looking from the bottom, this base of the geometry is completely visible? Yes, absolutely right. So in this example what I have taken, the base of the geometry is a square, is a rectangle. Henceforth the complete rectangle is visible. So what in this actual case, the geometry is a pentagon. Henceforth the complete pentagon is visible. Let us construct A dash to B dash, B dash to C dash, C dash to D dash, D dash to E dash, E dash back to A dash. Yes, so this is completed. Next, a line from O to O1. So this is the point O1. So O to O1 is the axis line. So let us write it as a axis chain line representation with a minimum thickness, big, small line, big and small line. Yes, this is O to O1. This is also over. What is the condition of 1 by 1? O to E, O to E and O to B. Observer is looking from this end, O to E, O to B. I mean E and B point are close. Please do remember one more concept. This is the outermost boundary. Outermost boundary is always visible even though if it is invisible. You can make a note towards the side of the paper. In the sixth position, whenever you are drawing a line from O to E, this becomes the outermost boundary. This is the last line you are drawing for that boundary. I mean for that particular side. Henceforth, it is always visible. The same line of explanation, O to B also forms the outermost boundary. It's visible. Next, what is the condition of O to A? O point is here, A point is here. A point is extremely close to the observer. Henceforth, O to A is visible. But O to A is already an axis line. It has been shown as a part of the axis line. Erase the axis line, show it as the continuous line, I mean visible line. The last O to C and O to D. O point is there here, C point is here. So don't you think it is far away from the observer? So O to C, O to D becomes invisible. I will let you know one more rule. Take a note towards the side of the paper. What is that O to C and O to D? No two lines will be same. Don't you think whenever you are drawing a line from O to D, it is crossing the visible line and moving? Henceforth, this should become invisible. Whenever a line crosses the visible line, it becomes invisible line and the vice versa. I repeat, O to C dash, the last line, analyzing the last edge, O to C. Don't you think it is crossing the visible line here? So this becomes invisible. So this would be the solution. This is called as the true shape. And this is the apparent shape. If you want to show the flow of line, so let it be like this. This completes the solution. Hope you have enjoyed this video. If yes, give this video a thumbs up, share with your friends. Don't forget to subscribe. I will talk to you in the comments. Thank you. Have a nice time. Bye.